I need you to write chapter 3, lesson 1. Chapter 3, lesson 1. Shh. Take notes. Put the water bottle down, please. Take notes. The title of the lesson is Relate Multiplication to Division. I'll take this. Thanks. Everybody write that down. Relate division to multiplication. So here's what that means. We're going to talk about how division and multiplication are opposites of each other. And how if you know your division facts, you know your multiplication facts. And if you know your multiplication facts, you know your division facts. And those are called fact families. So when you were in like first grade and second grade, you talked about fact families a lot, except you talked about fact families like addition and subtraction, because those two are opposite of each other. And so now we're going to do the same thing, but we're going to talk about multiplication and division. And how if you know one set of facts, you're going to know the other set of facts because of the three numbers that are together. So let's see. Our essential question, because we're now starting a new chapter, is the strategies that can be used to divide whole numbers. So this is almost the same strategy as essential question as chapter 2, except now we're going to be talking about division instead of multiplication. So before it was what strategies can be used to multiply whole numbers, and now we're talking about division, numbers that can be used to divide. Angelina. They are. They're related. That's part of what we're talking about today. You're right. We're going to skip by a couple things here and get to this one. So our question today is, how do you determine what numbers are in a fact family? Because you can't just throw out three numbers, 2, 12, and 152. Those are not necessarily a fact family. It's not just any random three numbers. So we have to talk about how we can tell which numbers are in a fact family together. So let's first define what a fact family is. So this is in your notes. So a fact family are numbers that are related. That's why we call them a family. There's more to this than just that. So write down that sentence and then we'll kind of talk about it a little bit. You writing down? Write down what I write up there, okay? You don't have to just write the words that I just wrote. And so they're related because you can multiply or divide two of the numbers and you get the third number as your answer. So we're going to write that also. We're going to put a big X to save on some space. So you can multiply or divide two of the numbers. And the third is your answer. So a fact family is made up of three numbers. Every time a fact family is made up of three numbers. So you can multiply two of the numbers. So if you were multiplying, you'd be multiplying the two smaller numbers and getting the larger number as your answer. And then if you want to use division, you take the biggest number, the big number, and you would divide it by either of the other two numbers, and you're going to get the other number as your answer. So those three numbers will always work together as part of your fact family. So in your notes, while I'm letting people finish copying this, I don't want to erase this, but I'm going to write a fact family, and I want you to see if you can write all of the problems, all of the math problems that would go along with these three numbers. So the numbers are 20, 5, and 4. So in your notes, write 20, 5, and 4, those three numbers. And then underneath it, I want you to write any problems that you could make using those three numbers. So for example, 4 times 5 is 20. That used all three of those numbers. So that's We took two of the numbers, we multiplied them together, and we got the third number as our answer. So 4 times 5 is 20. I used a 4, I used a 5, and I used a 20. I used all three numbers. And if I wanted to use division, I could do 20 divided by 5, and that would give me 4. Now there's a couple of other problems that if you mix some of those numbers up, you could make up a couple more. So think of all the other problems that you could make using those three numbers. I'll give you a second. So what's one problem I could make with 25 and 4? Karnpreet.
Or 5 divided by 20.
Oh, it would be 20 divided by 5 because your big number always has to come first. So 20 divided by 5 equals 4. Cameron, what else?
20 divided by 4 equals 5.
That would work also. Sean.
5 times 4 equals 20.
5 times 4 equals 20. Seema, what's the other one?
4 times 5.
4 times 5 equals 20. So write down all of those facts. Yeah, hurry, you're going to miss some notes, so you got to be fast. Here's another example. 21, 7, and 3. So in your notes, I want you to write all of the problems that you could make using those three numbers. Okay, so what numbers did you come up with 21, 7, and 3? What problems could you make? Angelina. 3 times 7 equals 21. Nolan, what did you come up with?
7 times 3 equals 21.
7 times 3 equals 21. Samir. 21 divided by 3 equals 7. Tristan C. 21 divided by 7 equals 3. So if you know one, then you just flip-flop the other two numbers, right? And that's basically what we're doing. So we're mixing some things up in there. Let's do one more example in your notes. 5, 35, and 7. What's one problem you could make with those three numbers? Karnpreet.
7 times 5.
7 times 5, what's the rest?
5 times.
No, what's the rest of that? You said,
7 times 5 equals 35.
there you go. You just didn't give me the answer. What else, Cameron?
35 divided by 7 equals 5.
Yep.
I know the one.
Vicky.
35 divided by 5 equals 7.
Yep, 35 divided by 5 equals 7. And what's another one? Catherine.
5 times 7 equals 35.
5 times 7 equals 35. Good one. So this is what we're doing today. So in your work, they're going to ask you what fact family could you make using these three numbers, what problems could you make using this fact family? And sometimes they'll give you the problems and ask you what's the fact family related to these problems. They'll ask you to do the opposite. So still in your notes, I want you to read this question. We're not going to use counters to model the cards because you don't have counters in front of you. So just look at the question. A matching game uses 24 cards. Describe how you could arrange the cards on a table so there are an equal number of cards in each row. What numbers would be in the fact family that describes your arrangement? So because they were asking you to use the counters, that's those little circles on the side. So if I pulled out 24 of those, like how could you arrange it to where there's an equal number on each of the sides? So basically you're making an array. And there is more than one correct answer on this. So you're going to make your own array using 24 counters. Okay? So Angelina says if I make a row of 6, there's 6. If I make a bunch of rows of 6 like this, I would have 4 rows of 6. Do you guys agree?
Yes.
That sounds right. So if I so your fact family would then be 6, 4, and 24. So you could do 6 times 4 is 24. 4 times 6 is 24. We could also use division. 24 divided by 6 is 4. 24 divided by 4 is 6. What's another way you could arrange these counters, Aiden?
3 across, 8 down.
3 across, 8 down. So if I did 3 like this, then we would have a row of 8 here. I'm going to need 3, 4, 5, 6, 7, 8. Then if I filled all of those in, they're just counters. It's just a visual for you to see.
We draw a box.
Oops. Oh, some disappeared. 1, 2, 3.
Yeah, that's right.
Like that. Oh, I know why. Hold on, because these ones aren't in a row exactly. There we go. I did. One disappeared on me because I threw it up on accident and it disappeared at the top. And then I had one extra. Okay, so your fact family here would be 3 times 8 is 24, or 8 times 3 is 24, or 24 divided by 3 is 8. Hold on. Or 24 divided by 8 is 3. That's another way you could do it. What is yours? Corn free. 12 times 2, he says. So if you have 2 rows and you've got 12 in each row, well, 12 times 2 is the next factor. You didn't invent it. It's just the next factor.
It's not Cameron. It's not like 24. It's not like Cameron and 12 times 2.
There's really only these 3 right answers. Okay. How about we all stop tattling on each other? There's only 3 fact families that you could... Okay, there's 4 fact families that you could use. Sean, do you know the last one?
10 plus 2.
No plussing. Multiplying only.
Okay.
Yeah. What if you make one big long line of 24? One row of 24.
I have 4 of them.
Because there could be 1 times 24. There could be 24 times 1.
You're right. You're right.
Go up and then go down.
You're right.
Plus on.
Yes, you could do that. Let me clear this somehow. That's a lot of noises. Example number 1 says Cheryl's helping to put away 18 basketballs after practice. She places them on a rack that has 3 shelves. How many basketballs can she put on each shelf? So this question goes along with this lesson because we've been talking about fact families and which 3 numbers, how 3 numbers work together. And they've given you 2 out of the 3 numbers. So now you have to decide which is the 3rd number that goes with this fact family. See how they've drawn it here like a triangle down here on your paper? Triangle because triangle has 3 corners. And we're talking about 3 numbers that work together. So you could multiply these 2 of the numbers and get the 3rd as your product. You could divide 2 of the numbers and get the 3rd as your quotient. Either way, you're going to use all 3 of those numbers. So what is the number that's missing? Angelina? 6. And if you wanted to draw a picture, she's got 3 shelves and she's putting basketballs on all of the shelves. She has 18 basketballs to place. So it's kind of like what we just did with the counters where we were seeing how many, if we had 3 rows, how many would be in each row. So if you went like this to put the basketballs on the shelves and you counted all the way up to 18, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's 3 equal shelves, each having 6 on each shelf. Yes, Angelina?
There's also a shelf on the bottom that it will make you basketballs on the bottom of the page.
Oh, okay, you're right. So I don't see that one on my thing. So, oh, good. I'm glad I showed you that then. So on the bottom of your page, you have the little shelves, and you're drawing 6 basketballs on each shelf. Did you notice how I put 1 on each shelf to make it even, and then I put a second one on each shelf to make it even, and I had to keep counting up until 18? So that's what you were doing there. So now we got to fill in all the fact families. So we have 3 times 6 is 18. So then if we switch that, we would have 6 times 3 is 18. If we divide 18 divided by 6, we would get 3. And then 18 divided by 3 is 6. So 18 is our total number. If we're going to divide that by 3 shelves, that means we have 6 basketballs on each shelf. So you can fill in all of those little blanks that you have there. 6 basketballs on each of the 3 shelves. Here's your, this one looks better than my drawing. So you have 3 shelves. And then if you drew all the basketballs in, you have 6 times 3 is 18, and 6 basketballs on each shelf. So fact families is something that if you haven't memorized all your basic facts, fact families, like if you think about it as fact families, that really helps you to memorize. Because if you know your 3s really well, then you know one of your 6s too, right? Because 6 times 3, 6 times 3 is the same as 3 times 6. So a lot of them go together, and you have to be able to recognize that. Same with sometimes when we do our time tests and we have division ones pop up in there, then everybody kind of freaks out because they're division facts. But if you know your multiplication facts really well, then the division ones should be just as easy, because it's really just the same numbers mixed up. Okay, so that's what we're talking about, and so that's going to help you when you're doing word problems. It's going to help you on all types of problems, not just like in this lesson they give you the 3 numbers and want you to write all the fact families, but it's not only when they give you problems like that, but it's going to be just through lots of problems where you'll use fact families to help you out when you have a missing number. All right, example 2 says, Ellie is creating gift bags for her party guests. She wants to divide 56 pencils equally among the 7 gift bags. How many pencils will go in each bag? So this time they've written an equation. So the equation looks like this. We're going to get into writing equations in a future lesson, but they kind of gave you a little bit of an introduction into doing that here. So they're using the letter P as an unknown variable. So the letter P represents the number of pencils that are going to go in each of the bags. So it's unknown because we don't know what it is. So we're talking about algebra a little bit here, because algebra is where you use letters to represent numbers when you don't know what they are. So 56 is the total number of pencils that she has, and she's going to divide them equally among 7 bags. So then our equation is going to look like, I'm going to write it bigger, 56 divided by 7 equals, and we use the letter P to represent the pencils that are in each of the gift bags. Now if you haven't really studied your basic facts a lot, this will probably be a little harder. But think about what number times 7 is 56. So what is the number that's missing? Because this is a division problem, but we could use multiplication to help us solve it. Hamza, what do you think? 8. 7 times 8 is 56. So that means 56 divided by 7 is also 8. Remember the triangle? So 56 is one of the numbers, 7 was the other, and 8 was the third. We could use those in division or multiplication. See, we could use those 3 numbers in lots of different ways, like what we've been talking about. So because 56 and 7 are 2 of the numbers that are in our problem, we know that the third number must be 8, because that's part of the same fact family. So that means Ellie will put 8 pencils in each bag. Can I see that paper? Yeah. Okay, so what you're going to see today, if you turn your page to, let me show this one so I don't have to show everybody individually. So if you turn your page to the independent practice page really quick, this one, see how there's some paper clips? There's some other ones with the little blocks that are clipped together. Now it says, write a fact family for each set. So you're looking at the array. Remember what we just did with the counters, and I put them in a certain order based on what you guys told me, like 8 rows of 3, or 3 rows of 8, or 12 rows of 2, or whatever it was. So now, this is what you have to look at. So we're going to look at the first one here together. You have 3 across, and you have 1, 2, 3, 4, 5 down. So that would be, how many do we have in this whole? Let me use this triangle method again to show you. So we have 3 across, we have 5 down. So how many paper clips do we have here all together? Malachias? 15. So those are our 3 numbers in our fact family, because we have 3 across and we have 5 down, and we know that if we multiply those 2 numbers, that'll tell us how many are there all together. So you have a total of 15 paper clips. So the 4 problems I could make would be 3 times 5 is 15. Then we could do 5 times 3 is 15, right? Just make that opposite. Then we could do a couple of division problems. 15 divided by 3 is 5. And 15 divided by 5 is 3. If I put this, I just want to make sure you realize that is not the same thing, right? This and this, not the same thing. This is not the way you would want to write that problem. The bigger number goes first when you're writing it, when you're writing a division problem. The number that you're dividing into. So 15 would have to go first on that one. Otherwise, you're going to get a negative number or something, a decimal or a fraction, something like that. So we're not doing that today. Everybody see that? Yeah. The other one, you've got 1, 2, 3, 4, 5, 6, 7, 8. So you've got 2 rows of 8. So 16 total. So your fact family numbers are 2, 8, and 16. And then you can make all your fact families based on those numbers. Okay? Make sure you do the guided practice questions. The 2 questions there that are for guided practice. Make sure you compare those with your neighbor. Make sure you're getting them right. If you did, then you can move on to the independent practice, and I'll put up your 20 minutes.